let's see. Okay, so what we are going to do, we are going to use this Bartle book and do some exercise from this Bartle. Pull your chair. But to get into the interesting part, we're gonna skip some of the chapters and then go straight to some inequalities, because the beginning is basically just sets and also some math induction and so on. So let's start with something that probably not very well. Can you turn on the light? Okay, so let's do it, Mr. Akang. So let's do number 1A. We want to prove that if A less or equal to B and
That's just less than.
less or equal C
Oh, okay.
and C
Yes,
less
that
than
kind of less
T,
than equal.
proof A plus C is less than B plus T. So the axiom that we have for this inequality is basically just if you have an inequality and you may add both sides with the same number and it preserves the inequality. So like if you have A less B, and for any C we have A plus C less than B plus C. Okay, so let's think about how we can manage to prove this just using that property. So if you look at this, and then so this is the given information, right? And this is our objective. So then we want to somehow relate this information to this expression. Let's say we want to get A plus C. So what we can do to make that expression appear?
You should add C to. Wait,
C,
actually,
so-
you want.
Okay, let's try. So according to that axiom of order, then A plus C
Less than equal
is
to.
equal to this B plus C. Okay, but at the same time we want to have something like B plus D, right?
Yeah.
So how can we get that kind of expression?
You can add B to the other thing. Add B to C. Yeah.
Okay, so because C less than D, this implies that
B plus C
B plus C
is less than B plus
less
D.
than plus D. Okay, so now how we can use these two information to conclude this?
Yeah, you can just A plus B is less than equal to B plus C, and B, since B plus C is less than B
Okay,
plus C.
because of the transitivity of the inequality. This guy and this guy is less than
B plus
that guy. So therefore A plus C is less than B plus D. Good. Let's do part B.
Part B. Oh,
What is part B? If A less or equal to B and C less or equal to B, this is basically similar, I think.
A plus C, B, B.
We can ignore it. It's similar. The difference is just here we have also
Yeah.
less or equal, and that it's gonna be the same. Okay, let's do number 2. A. If
0 between
0 A B and 0 C D, prove that
A0 AC. D.
Okay. And the only property that we know is that if we multiply an inequality with a positive number, then it preserves the inequality. So using similar idea, we want to get something with AC. So how can we make it appear? this AC thingy.
You multiply the first inequality by C and the second one by B probably.
Okay.
I mean, wait, by A.
Okay, so what's the
Wait,
consequence of this?
Consequence is at 0 AC BC.
Okay, and then what's next?
If you multiply by A, then you just get AC.
If you want to get
and-
this.
No, you want to get BD, so you multiply by B.
Oh yes.
So you just get BC, and then BD, and then same transitive property.
Yeah, so we just use what we need. AC, BC, BD. Therefore, 0 AC less than BD. It's similar,
It's,
I think.
no, it's also shown by example that it does not follow that AC less than BD. It does not follow.
Let's put some C equal to 0 and D equal to 0.
But, oh, wait, huh? Oh, it's less than equal to, okay, yeah, I see.
Skip.
3.
If A less than B and C less than D, prove that
AB plus BC. We
AD
don't know that what's it
plus
called is.
BC less than AC plus BD.
We do not
Yeah.
know that they are the what?
Positive, negative.
Or
But
zero.
still, we can still do it. I
Yes,
believe.
don't do it. But then, like, you need to split by case in that scenario because it might change. Or is it like always going to be this way?
Let's see. Maybe we need to rewrite first this in another way to make it better. So, for example, usually this information, because everything is depends on the positiveness or negativeness of things, right?
Yeah.
So then rather to write this as A less than B, you can write it as B minus A is positive, and maybe somehow you can use it.
B minus A is positive.
So what I'm trying to say is try to rewrite this so that perhaps B minus A or D minus C appears in this expression, so that you can somehow manipulate that. So how to change around, I mean, which one moving to the left hand side and which one moving to the right hand side, so we can force it so that B minus A appears, for example.
You want A, B, A, C. You want all of them to appear, right?
Well,
I mean, all the
yeah,
combinations.
maybe D minus C or B minus A. So which one I can put to the left hand side and which one goes to the right hand side?
I mean, like, you put all the you put the D or the C's together, I think.
So then which one?
Like the AC goes to the
Okay.
left and
AD minus AC plus then. So basically we are doing backwards. So we say that this expression is equivalent to what expression? Hoping that we can get something, some expression that
we can use
easier, right? So
AD
so
minus
what we do is
AC
just
less
just
than
restate what we are trying to prove. And this one is what? A. See, our objective, as I said before, that to somehow using the positiveness from this or that, which is the positiveness of B minus A or the positiveness of for D minus C.
BD minus BC minus AD plus AC is bigger than 0, right?
No.
Oh.
Can you see that you can have D minus C expression from this guy?
Oh, yeah.
How?
Like if you divide by A, then you have D minus C.
Not divide, but
not
you
divide.
factor out.
It's A times D minus C
And this is
is less than B times D minus
see,
C.
now you can see. So because this guy is positive,
Then you have
then we can get this
A less than B.
as long as A less than B. But it is true A less than B.
A less than B.
So then the way we write the answer that you can uh, since C less than D, then
D minus C less
D
than
minus C is
bigger
positive.
than 0. Yeah.
Now from A less B and D minus C positive, A D minus C less than B D minus C, but this guy is equivalent to this guy.
AD plus BC and BAC.
Okay. 4. Find numbers A, B, C, D in R satisfying. Find example of number C, D less than 0. Such that either 1, what is 1? AC less than BT, or 2, BD less than AC. So when you find example of ABCD, so that the first or the second one is true.
Okay, A, B, C, D, 1, 2, 3, 4. Like that's gonna get one of them, obviously.
1.
But
What is A and B?
1, 2, 3, 4.
But this one need to be
Oh,
negative.
it needs to be negative. Oh, okay. I did not see that. That's what negative 1, negative 2. Oh wait, it's less than, so
So you want to make this AC small, right?
yes.
Then just make this
very,
very
big
very negative.
number.
Yeah. So what do you suggest?
Negative 5. Another one's negative 1.
Okay. Then
AC is negative 5.
AC 1 times negative 5 is less than 2 times negative 1.
True.
Okay, how about this one? It is either, but can we also find this one or not? Oh, we can. So what is the example for the second one?
You want BD to be very big. You want BD, so just make the 2 here like some really big number. So 0, 1, 2.
One, you want to be big, the B1?
Oh wait. Oh, you want
So it's very
10
negative, like. And then this one.
is with the negative 2, negative 1, 0.
So then AB
Wait, BD.
or BD
BD is negative 10. AC is negative 1.
10 times negative 1 is less than
1 times negative 2.
1 times negative.
Yeah,
Okay.
Like AB and oh, I show that A squared plus B squared equals 0 only if okay.
If AB are real numbers,
And A squared plus B squared equals 0.
A squared plus B squared equals 0 if
Right.
and only if
A equals 0.
A equals 0 and B equals 0.
I mean, you can do the right side easy.
So from where to
From
where?
right side, if A equals 0 and B equals 0, then A squared plus B
Okay.
squared equals 0.
Yeah. If AB equals 0, then
A squared plus B squared.
A squared plus B squared is equal to 0 squared plus 0 squared is 0. Okay.
The right hand side, because a number squared is always not negative.
Since A squared
That's 0 and B.
and similar, so A squared, but we already know that's equal to. Okay, it's okay.
A squared plus B squared must be.
But we start with this already. So I think usually to get a convincing argument that you use the contrapositive.
The contrapositive. Okay.
So what is the negation of this?
But A is not 0, that's just the negation is no, you can't really.
A is not 0 or B is not 0.
Oh, that, yeah.
Yeah. So if A is not 0 or B is not 0,
then A squared plus B squared is also not
let's
0.
say A is not 0 without loss of generality.
Yeah.
Then what? A squared will be positive.
A squared is positive.
Follows A squared plus B squared will be
Because,
positive.
yeah.
I don't know how elementary we can go from here. Okay, maybe we can.
No, it's true then. That
I know it is true, but I mean,
the
like
contrapositive.
the reader, they expect something more elementary argument.
Since B squared is greater than 0, and A squared plus B squared is greater than 0.
So if it is not this, then it is not that.
Yeah.
So it is.
True.
6. If 0
A,
less or
B.
equal to A less than B, proof A squared less than AB less than B squared. Show by example.
Okay, so
Not
the A and
true.
B are positive.
That A squared less than AB less than B squared. Okay, so prove the first one.
Oh. So you have to show an example to equal after this one. This one, yeah. Okay. So because A and B are both positive, then you just like multiply. You can multiply A less than B by A. You can also multiply A less than B by B.
A less than B by B.
And then you just multiply A less than B by B, and then A less than A by A, and then you have.
But need to be careful if we multiply by A, because A is not really positive. If we multiply by B, that's okay.
Okay.
Since B is positive and A less than B, then AB less than B squared. Okay. What is the other one? Then you can just like consider two cases. A is equal to 0.
Oh, A is bigger than 0.
And then A bigger than 0. If A is equal to 0, then A squared is equal to 0, equal to AB.
Yes, which is less than B squared.
If A is positive, since what do we need us?
We just multiply A. We just multiply A.
I know, but we need to bring it into the argument. Like the reader maybe forget what is known or thingy. So we need in the argument we need to bring everything that needed to implies this, right? So we can implies this when in the beginning we have A less than B, and then you multiply by A.
So have A less than B and you multiply by. Well, I mean, this one we have A less than B and multiply by B, right?
Sorry, we have what? We want this, right?
Yeah.
And then we multiply by A this one. And since A less than B, then A squared less than AB. So in all cases that A squared is less or equal to AB, can be equal or smaller. So then you need to conclude again, because we need to make it into a habit that we make sure that we state
The final
the
thing.
final thing that we are being asked to show. Okay, next the example, which is exactly this one, I guess.
Yeah, that was 0.
Oh, okay, skip. 7.
Oh, square root.
Show that if 0 less than a less than b, then a less than square root of ab less than b, and 0 less than 1 over b less than 1 over a. So again, we always need to think of how can we achieve the expression in our objective from the given information. So for example, how can we get 1 over b? What we do to this guy to get 1 over b and 1 over a?
Okay, they're both positive this time.
Uh-huh.
So you can do the multiply by a and then multiply by b thing. So you have
Which one? This guy?
no, you have to get the square root thing. So like you do, because we have this, you can have this, but without the, you can have this. With the 0 ab, you can make this, right? And you can square root it.
Huh? You want to get this one?
Yeah, I'll get that one.
Oh.
That means it's, yeah.
Okay. So from 0 less than a less than b, according to 6, what? A square less than ab.
A squared less than ab less than b squared, and then you can take the square root because they're all positive.
Uh-huh. So just to make sure that you know. Okay, and then you write a less than square root ab less than b. Since ab positive.
Yeah,
Yeah.
okay. Done. Yeah. Other one.
The other one.
Just like, do you I mean, flipping is like, it is pretty, why does flipping work? I mean, I guess this is what it's asking, right?
Yeah, but you can think of algebraically. So how to get what kind of operation you do to this guy to get this guy?
You divide
Divide by.
itself squared.
Hmm?
Like you divide b by b squared,
No,
you get 1 over
when
b.
you need to divide with something consistent, which resulted in this expression 1 over b and 1 over a. So what is exactly? You divide by what?
ab.
ab. Okay. So dividing is basically multiplying, right?
Yeah.
So basically you want to use the argument that you multiply with 1 over ab. So we need to know the positiveness or negativeness of this 1 over ab.
Then we know it already.
We can use from here. So since
A and b are positive, then 1 over a, 1 over b must also be positive.
okay,
Then 1 over a is positive, 1 over b is positive, so that means therefore 1 over ab is positive.
okay, let's just make it more satisfying for us. Actually, so sometimes when I beginning learn this, is like I get some satisfaction just to make it very detailed for myself, something like that. So like certainly you know that this one is, you can go right away here, right? But like we want to make sure that the step is understood by the dumbest person ever, even. Okay, and it follows what?
that a less than b,
So
from a less than b, that equals
implies a times 1 over ab less than
b, ab,
so 1 over b
b
less than
1 over a.
okay.
Second that.
What is the positive one? Okay,
It's positive, yeah.
0 1 ab. Okay.
If n is a natural number, show that n squared is big or equal to n. We counting 0 here?
No.
No. Oh, it's 1, right? I forgot.
This guy using 1. Your book using starting from 0. Natural number. Hence 1 over n squared less or equal to 1 over n. So how do you do this? N squared less or equal to n.
So you, it's induction. This is induction, isn't it?
Don't use induction.
Don't
Just
use
try
induction.
to avoid induction.
Right, avoid induction. Oh,
So
okay.
instead of this, you rewrite it into something more convenient. Just move everything.
You get the
there.
thing. And n minus 1 bigger than 0.
So now basically you want to somehow making an argument to say this product is not negative. How to do it?
What? Because n is n, the smallest, there's a smallest guy, right?
No need, you just need for general n. So basically in order to have this positive, it is enough to say that
That's
both of them are positive, or the worst is one of them is 0. Right?
Yeah.
So you say that since n is in
natural
n,
number. The smallest possible n is a 1.
and
Yeah.
the
Which means therefore
n minus 1 less than
equals to 0.
0.
You
So
multiply by n.
It follows. Yeah.
Yeah.
Okay. Since n's. Oh.
It's how this weird string it.
Okay. Positive.
Since n is positive and n minus 1 is greater.
Okay. Okay. Until 10. So 9.
Oh, we didn't continue to 8, but I don't think we need to, right?
Huh?
We don't need to do this part.
Just use.
It's the same as 7.
Yeah, okay.
That's
Skip.
them because they're both positive.
Find all real numbers such that. So basically, this is solving inequality, but we just need to be careful that we use all the
All of them have every number.
property we know about this inequality. So basically, we just
X squared
add
minus
with negative 3x both sides, add with negative 4 both sides.
X squared minus 3x minus 4 is bigger than 0.
And then we can factor become what?
4 1, right?
Negative 4.
Negative 4 1. X plus 1.
Okay, so basically, if we use word x minus 4, x plus 1, both positive,
Both negative.
or x minus 4, x plus 1,
Both negative.
both negative. So it means that on the first one, x bigger than 4 and x bigger than negative 1, or x minus 4 less than 0, which is x less than 4, and x less than negative 1. So if we use n, this can be simplified into what? So at the same time, our x is greater than 4 and greater than negative 1.
Greater than 4.
Greater than 4.
X greater than 4. Or x x less than negative 1.
It's not. Okay, I think it's okay. Maybe this the last one. So 1 over x less than x squared. So how do we do this?
All real numbers. So it's everything between. It's everything past 1.
What everything percent?
I mean everything is like bigger than 1, less than negative 1, right? I think should be.
I don't know. But how do we
Prove it.
proceed from this information?
It's real numbers, so you can't just. I mean, you can just minus, right? Just minus both sides. You still can move some.
Okay. And what?
Less than 0. Okay. Yeah.
Well, basically it's just like fraction. You just want to rewrite it
Yeah.
so you can combine the two
X
two
squared is
fractions.
x cubed over 3. X cubed over x. And you have 1 minus x cubed over x less than 0. And you can multiply by x. No, you can't multiply by x both sides.
And you need to factor 1 minus x cubed. Do you know how to factor 1 minus x cubed?
Oh no, I do not.
At least you know one of the factor is 1 minus x.
Yeah.
So the other one is 1 plus x squared.
Oh. Less than 0.
And this guy is always positive. You
Why is
somehow
he
use the
always-
argument of the discriminant is negative.
Okay.
But b squared minus 4ac. So this is 1 squared minus 4. Negative 3, negative. So if it is open up, so this parabola is open up and it's not touching the x-axis. So then this is above the x-axis.
Positive.
It's positive. So since it is positive, we are allowed to divide with this guy.
Oh, okay. Yeah, and then you just have 1 minus x over x is less than 0.
Then in order this division to be negative, they just need to be of different sign. So 1 minus x positive and x is negative, or 1 minus x is negative and x is positive. Right?
I mean, wait. Oh, never mind. Can't you split it again? You can also split it again, right? Why have you split it again? So you get 1 over x minus 1 is less than 0.
But
You have 1 over x
but
is.
then you can. I mean, if you do this, you don't know how to deal with it because you are not allowed to multiply with x. You don't know the x unless you divide.
And
If
you
x
have
is
to do
positive,
this again. You have to do that
yeah.
again anyway. Okay.
So the first statement is equivalent to what? So x bigger than 1 and x less than 0. Is it possible?
X bigger than 1, x.
Sorry, x less than 1 and x less than 0.
X less than 1, x is smaller than 0.
So 0. And x bigger than 1 and x bigger than 0.
What?
This one
Oh, that
and this one. So at the same time, x is greater than 1 and x greater than 0. So what is the intersection between
x is bigger than 1.
x bigger than 1? Okay. So then this is it.
X less than 0, x bigger than 1. Is that true? What's the thing we're looking for?
1 over x less than x squared.
1 over x less than x squared.
If x is negative, certainly it is true.
Oh yeah,
Because
yeah.
it's calling negative, this one is not negative.
Okay, yeah.
If x bigger than 1,
Then
it's
it's
gonna be smaller than 1.
Yeah.
And it's gonna
Okay,
be
so
big.
yeah.
Okay, one more. 10.
A, B,
This epsilon thing is similar
epsilon
to
thingy, that thing. A and B real numbers, was that for every epsilon?
epsilon positive, a less equal to b plus epsilon.
Epsilon.
Show
A less
a
than
less or equal to b, and b if not true.
And show that A can equal B, basically what it's saying. Right? A less than equals to B, but it's not true that this, which means A can be equal to B.
Oh, repeat again.
Show that A equals B is a possibility, basically. Yeah. I mean, like this, because this can vary. It's still true. A less than, actually no, it isn't. Never mind. Yeah. To show that A can equal to B, and then yeah. Okay. Epsilon. Hello, epsilon.
So to make a convincing argument from this,
A is always less than B plus epsilon for every epsilon that is positive.
I always do, if it is something like this, I always do the what's wrong if it is not. So
So
assume not. Assume on the contrary not. So what's happened?
A is bigger than B.
We need that so basically
Then you will find an epsilon.
in your picture thingy, this is A and this is B.
Yeah, so if you want to prove the contrary false, right? So like, yeah, you want to prove the opposite false, yeah?
Now what I do is contradiction.
Contradiction.
It's
Okay.
a bit different.
I mean, you're gonna find a guy that calls this.
So we need to find an epsilon so it falls here, because the claim is here, right?
Yeah.
For every epsilon.
Oh yeah, we did this.
Yeah, we did this.
Like
So what is this epsilon?
It's the A plus B over 2 thing.
A minus B over 2.
Oh, A minus B over 2, yeah.
Yeah, the location is A plus
minus
B over 2, but
that.
the epsilon itself.
It's so the location is A minus B over 2, right?
No, the location is A plus B over 2.
Oh, the location is A plus B over 2, so then
but
you just
the distance is
subtract by B,
which is
A plus B
A
over
minus
2.
B over 2.
Yeah.
That's epsilon. Take epsilon equal to A minus B over 2.
Is that always going to be positive?
Then B
Always
plus
going to be positive.
epsilon is B plus A minus B over 2, which is what?
B plus epsilon.
This is B over 2 plus A over 2. But because B less than A, this is less than A over 2 plus A over 2, which is A. So B plus epsilon less than A. But how the assumption is A is always less equal, so contradiction here. Okay, so it means we cannot have this one, cannot swap A and B. So A should be less or equal to B.
If you want to show that A is allowed to be equal to B, then so you have two numbers. Oh, well, that's easy. That's really easy.
So it says that it is not necessarily true that A must be less than B.
So I mean, if A and B are the same.
Yeah, A and B. Okay.
I mean, if A equals B, then A is always going to be smaller.
But this is about like counterexample, so you better just pick a specific example. So it's like let A equals B equals 1. Then for any epsilon positive, clearly
A is
less or equal to B plus epsilon. But
A is less than.
not true let A less than B.
Yeah. Okay.
Okay, done. Dismiss. Thank you. Nobody watching. This is my English channel.